Hello, thank you for checking out Mr. Ware's videos, and today we are looking at a EOC review for Integrated Math 1. Go through a few different questions, and that's pretty much it. So let's take a look. Okay, here's our first question. Which of the following coordinates axis would be appropriate to use to represent the set of ordered pairs listed below? So you're going to take a look at these and figure out what graph is best to graph them on. Okay, so the answer is B. B. If you look here, you see some of these numbers are bigger than 25. All right, 44 and 45. So you need something that goes from 0 all the way up to 50 for the y-axis. So all these y's here. Since that's the only one that does that, that's why I picked that one. All right, let's look at another question. Eva measures the mass of her pet lizard each month. She wrote this equation to describe her lizard's growth. In the equation, x represents the independent variable and y represents the dependent variable. Which of the following can be the quantities that x and y represent? So we're talking about independent and dependent. Independent means it does it on its own. Dependent is dependent on something else. So y is the dependent variable and x is the independent. But look at the scenario. Think about what causes what and see if you can pick between A, B, and C and D here. Okay, the answer is going to be D, the time in months. So the more months it is, the bigger the mass or the weight of the lizard as the lizard grows. So the weight is dependent on the time. Okay, new question. A carpenter makes wooden chairs. He has enough wood to make 30 chairs. He makes $60 profit on the dining chair and $90 profit on the rocking chair. It takes him 1 hour to make a dining chair and 2 hours to make a rocking chair. He only has 40 hours available to work on the chairs. The carpenter wants to maximize his profit given the constraints. Constraints meaning he's got a limited amount of hours he can work. Okay, he draws the graph below to represent this situation. So you can see the chair profit optimization here. You got the rocking chairs on the left, which is the y-axis. You got the dining chairs on the x, and it shows you the options for them. So you got one graph for each one here. So what you need to do is, given the constraints, the carpenter can maximize his profits by making blank dining chairs and blank rocking chairs. See if you can fill in the answer. All right, the answer is making 20 dining chairs and 10 rocking chairs. Okay, and the reason I know that is that's the spot where both lines cross at the highest spot there. Okay, so here we got 10 for the rocking chairs and 20 for the dining chairs. Next question. A group of students want to approximate the number of students at their school that ride the bus in the morning. Select two options that will help the students create an appropriate estimation of the number of students who ride the bus in the morning. So take a minute and read all these choices and figure out the two that gives you the best. Okay, we've got A and D. Okay, you'll survey all the students to find out who rides the bus. Seems to be, it might take a while, but definitely can figure that out from that. Count the number of students on one bus and multiply that number by the number of buses. That won't work. So let's say you got 10 buses. Um, all of them got like 20 students, but this first bus only has like 8 students. It doesn't give you a clear picture of how many kids ride the bus. So, survey the students who are dropped off by their parents. That won't help you at all. Count the number of students on the third bus, then use on every third bus, and then use the average to estimate the total number of students who ride the bus in the morning. That gives you a clearer picture as well. And call one student and ask if they take the bus. That's silly. So, it's A and D. Ben has $100 in savings in his savings account, and he adds $5 a week to his savings, as shown in the graph below. You got the amount of money in dollars. You got the time in weeks. According to the graph, how much money does he have in his savings account after 8 weeks? So see, after 8 weeks, how much? You should get 140. According to this graph, how much money does he have in the savings account after 8 weeks? Go up to 8 weeks, it goes up to 140. All right. Select the solution to the system of inequalities from the following points. Select three that apply. So here, we're talking about the solution of an inequality. So see if you can find of these 6 points, which three is a solution. Okay, you should get A, D, and F. A, D, and F. Okay, so we got -5, 3, -8, -1, -3, -9. All of these is in this area. These three are not. This one's close, but it's on a dotted line here, and that does not. It's not part of the solution. All right. Which graph shows the solution to the system below? All right, so here we've got two equations. You see how you got one that has equal to and one that doesn't. So that means you got the solid line for the equal to and the dashed line for the one that's not equal to. Okay, so you can either shade this way, you can shade down here, you can shade up here, or you can shade to the left. Which one would have the solution for both? Okay, the answer would be B. B. Notice how this says less than and this says less than. So you go to each one of these lines and shade below that. So this one would shade all the way here. This one would shade all the way here. And where they overlap is in this area right here. All right, let's take a look at another question. Page claims that the solution to the system of linear equations shown below, -2, comma, -5, y is equal to 2x minus 1, -12x plus 3y is equal to 9. Which of these methods could be used to prove Page claim? Select three that apply. Okay, so it's going to be A, B, and E. A, B, and E. So let's start with B. Okay, let's start with B. So here it says graph each linear equation and show that the intersection of the lines is -2, -5. So, excuse me. So it's just going to be like if you graph both lines and you see where they cross at. Okay, you graph both lines, see where they cross at. That is going to be -2, -5. Okay. Uh, Now another way to do it is to take that 2x minus 1 and plug it in to y right here. Okay, and if you do that, it'll look like this: -12x plus 3 times 2x minus 1, which is the y, is equal to 9. And then solve for x. Okay, and then find the value of y. And then next, let's see, you could take, let me go back here. You could take this -12x plus 3y is equal to 9, and you could just solve it for y. Once you add 12 on both sides, like a literal equation, you got 12x plus 9. You divide by 3. Uh, y is equal to 4x plus 3. And then that's A here, where we solve for it and get 3 plus 4x. Let me go back. 3 plus 4x, right? And then set it equal to 2x minus 1. Set it equal to this one here and see what you get. Okay. And you find for x and then you plug it back in to solve the value for y to see this -2, -5. Both of those, all three of those, are the ways that you could prove that page claim is correct. All right, let's look at another one. All right, which of the following graphs represents a relation that is not a function of x? Go ahead and select the correct one. All right, it's going to be C. It's the one where if you draw a vertical line, it's going to hit it in multiple spots. Another way to prove that a function or prove that a relation is not a function is if you have more than one y for any given x. So here this is -4 and you got more than one y at that given x. So here you can see how these lines got the little hole in it right here. That means that this part of the line is not the same. So this passed the vertical line test, this passed the vertical line test, and this passed the vertical line test. C doesn't, so it's not a function. All right, now before we get to the next question, I want to go over arithmetic and geometric sequences with you. Okay, so here I found this screenshot of arithmetic and geometric sequence. The top are explicit, where you plug in the actual term that you're looking for and find what that value is. And the bottom is recursive, where you have to take the previous one to find the next one. Okay, this is what it looks like on the EOC formula sheet. And this is what it looks like in the book that we use, using f of n. Um, so it's the same equation, same formula. Feel free to write this down, but you'll need this to help you with the next question. Okay, so the first five terms of a sequence are shown below. Which of the following equations model this sequence? Choose two correct answers. So what you want to do here is first determine, is it arithmetic or geometric? Then once you do that, you can see which formula was used. And they could probably use more than one. They might use an explicit. They might use a recursive. Um, so take a minute and see if you can solve that. There are two correct answers. All right. So let's talk about F first. F, this first, let's talk about what sequence it is. It is a geometric sequence. We are multiplying by 2 each time. 12 times 2 is 24, 24 times 2 is 48, and so on. All right, so we put the initial term, 12, right here, uh, times 2, the number that we're multiplying, and raise it to the n minus 1 because this is the first term. This is 1. Okay. All right. So that's why F is correct. It falls in with this formula here, right? Put the first term times the common ratio of the number you multiply and raise it to the n minus 1. Now the other answer, B, this is a recursive formula, okay? The thing is, notice how they got f of 0. So what they did is they went back 1. So they took 12 divided by 2. 6 times 2 is 12. So if 12 is the first term, then 6 is the 0 term. So they put f of 0 and then used the exact same formula for geometric sequence that's recursive here. So they use the common ratio here, and you multiply it times the whichever term you're looking for, and you got f of 1. But instead of saying f of 1, they said f of 0. Okay, so that's how this is the correct answer, B. Okay, which of the following best describes the behavior of this function? Okay, does it A, the function decrease quickly at first, then continues to decrease more slowly as x increases? B, the function decreases at first, then increases as x increases? C, the function grows more rapidly as x increase? And D, the function grows at a constant rate as x increases? All right, the answer is C. The function grows more rapidly as x increase. So just because this is a negative doesn't mean it's not growing. So we start here and we're looking at the y value for the growth. Okay. So as we go to the right on the x, it's going up and it's going up pretty fast. So the answer is going to be C. Okay, the value of a recently sold at an auction. The value of a recently sold at an auction is expected to increase in value over time. The function v of t is equal to 12,000 times 1.15 raised to the t. Represents the value of the v of t at time t, where t is the measure in years. Since the something must be left out here, the blank was sold at the auction. Okay, which of the following statements provide a correct interpretation of the function representing the value of the blank? Select all that applies. So we got the function here, and what I want you to know is which one of these is a correct interpretation of what we have here. All right, the correct answer is C and E. All right, let's see something. So the reason is 15% and 12,000. 12,000 is the initial values right here. That's the y equals ab raised to the x. That a is the initial value, and this is the rate in which it's going up. Okay, each year that increases at a value of 15%. This is where you get the 15% from. So like I was saying here, y is equal to a of b raised to the x, or in this case I use f of x is equal to a times 1 plus r raised to the t. Okay, that's the regular normal growth formula. Okay, and it's growth because we got the addition in here. Okay, so if you're doing a percent, what you have to do is take that percent and change it to a decimal and then add it with 1, and that's where the formula comes from. In the one we're using, we got v of t is equal to 12,000. Okay, we're going to multiply times 1 plus 0.15. because we changed that percent to T. And that's how you end up with this as the question. What they want you to do is unpack it and see that this is going to be 15%. That's why it's C. All right, the value in dollars of a car A as a function of T, the time in years since it was purchased, can be found using the function A of T is equal to 18,000 times 0.81 raised to the T. The value of car B as a function of the time since it was purchased is shown in the table below. So we got two cars here. And what you want to do is be able to figure out which one of these is correct, which statement correctly compares uh, changing uh, the changing values of car A and car B. So take a minute and see if you can figure that out. Okay, so let's take a look at each one. So sometimes you got to use process of elimination. This is one of those here too. So let's start with the easiest part, which is the initial value. Notice how each one of these questions asks about the initial purchase or the initial value. So from car A, we know the initial value is 18,000, and car B, the initial value is 16. So car A is higher in A and D, okay, and it's lower in B and C. So we could off the top eliminate B and C, okay. So the next part is, um, does it decrease by a greater percentage, or does it decrease, or B? Make sure I read that right. A decreases by a greater percentage, and here it says B decreases by a greater percentage. So where do you find a percent? Okay, so not necessarily looking at the percentage, but I can see that this is going down by 0.81, and this is going down by 0.85. Okay, so that's why it's going to be D. Car B decreases with a bigger number here. We're multiplying by a bigger number. Now, how did I get this 0.85? Well, remember, this is just a kind of like a geometric sequence. You're going to multiply by the same amount each time, okay? And here we're multiplying by 0.81. So how did I find that number? I just took the initial value and divided into the second one and got this 0.81. Now I know I am multiplying this by 0.8, and this one I'm multiplying by 0.81, so B is greater, so that's why it's D. Alright, in the diagram, angle 4 and angle 5 is what type of angles? Alright, they're going to be alternate interior angles. They're going to go across the transversal, and they're both going to be inside. Okay, which rule describes this translation? Remember that translations is a slide. Okay, it's going to be B. B is take the X and we're going to add 6 and then subtract 3. So I'm going to the right 6 and going down 3. Keep in mind that this is the image, or this is the pre-image, and this is the image with the little markings on it. Okay, same thing on the graph. This A, B, and C. Let me go back one so you can see it. A, B, and C doesn't have the markings. This is the image, has the little markings, so I'm going from this one to this one. So I slide right 6 and slide down 3. The chorded plane below shows the location of isosceles trapezoid A, B, C, and D. Trapezoid ABC is reflected across a line onto itself. The key word here is itself. Can you write the equation, or what is the equation for that line? Okay, you should get x is equal to 3. So we're looking for a horizontal line here, because if I flip it onto itself, it'll be in the same spot. It wouldn't change at all, right? So if I flip it over the x-axis or anything else, it wouldn't be the same picture. It wouldn't look exactly the same. It wouldn't be onto itself. So if I flip it here, that way it'll be flipped onto itself, and this is the equation. You get this by looking at the horizontal line, and you got x is equal to 3. And when you see x, you might think vertical, but here x equal 3 means that on the x-axis where 3 is, I'm looking at every single y where x can be 3. Okay, so that's why it's a vertical line. Now, if we was doing a horizontal line, let's say here at 1, I would say, well, y is 1. So it's every single spot where x could be whatever, but y has to be 1. That'll be a horizontal line, and that would be y equal 1. Okay, so x is vertical here and y is horizontal, but we wanted the vertical one. That's the one that could flip onto itself. Okay, a designer for a floor company is laying out a pattern for a hardwood floor. She begins by placing one board across two parallel boards at a diagonal. She needs to find the measure of the angles formed so that the installer would know how to cut the rest of the floorboards. The designer pattern is modeled below. So here we have a transversal. We know the measurement of one of these angles here is 128. And it says which equations are correct. Select all to apply. So they're talking about angle A, B, C, F, G, and H. Which one of them has the correct measurement and which one does not? Remember that these two lines are parallel. Okay, the answer here is A, C, D, and E. Okay, so remember that this is um, usually when you have parallel lines, all the acute angles are equal and all the obtuse angles are equal. So here we have obtuse angles 128, B is obtuse 128, F is obtuse 128, and H is obtuse 128. And then these other angles are all 52. So then you look to see which one has the correct one, and that's it. All right, rectangles 1 and 2 are shown on the coordinate plane. McKenzie claims that a sequence of rigid motions carries rectangle 1 onto rectangle 2. Which of the following actions could she take to prove her claim? Select all that applies. So take a moment to read these and see which one. Make sure you're reading from which rectangle to which rectangle. All right, the answer is A, B, and C. So if we rotated 180 degrees, going from rectangle 1 to rectangle 2, it would be right here. Show that the reflection over x-axis followed by reflection over the y-axis carries from 1 onto 2. So reflected over the x-axis down to here, and then reflected over the y-axis over to here. Okay, that would work as well. Show that a reflection over the y-axis followed by a translation of 6 units down carries rectangle 1 onto rectangle 2. So if I take this rectangle and flip it over the y-axis and then slide it down 6 units, it would go from 1 to 2. Finally, show that the translation of 6 units to the right followed by a translation of 6 units up carries rectangle 1 onto rectangle 2. Tricky here. If I go 6 units this way and then 6 units up, that will work. But the problem is that's from 2 to 1. You got to go from 1 to 2. So they want you to slide it right and then slide it up, and that's off the graph. That doesn't work because we're going from 1 to 2. So D does not work, but A, B, and C does. All right, the yellow taxi company charges are based on the function y equal 2x plus 4, where x is the number of miles traveled and y is the cost of the trip in dollars. What is the best interpretation of the 2 in this equation? So what they want to know is, what does this mean in context of what the company charges? Okay, the cost per mile travel. Okay, so we got y equals mx plus b. One way to think about this is m is what you move and b is what you begin with. So 4 is the flat fee and 2 is every whatever it is. So in this case, it's miles. So 2 times every mile traveled. So 2 is the cost per mile traveled. The value of art sculpture is changing each year. The change can be modeled by the equation below, where y is the value in thousands of dollars of the sculpture x years after the purchase. Okay, so we got this equation, right? And it says, keep in mind that this is in thousands of dollars. Thousands of dollars. Okay, so the value of the sculpture is blank each year by blank. The initial purchase price of the sculpture was blank. And then click and drag the correct answers there. But see if you know which one goes where. Okay, so let's start with the first one. So here you have 1.5, which is positive, which means it's going up. So in the previous slide, I talked about how that 2 is how it moves, what it's changing. If it's positive, we're adding each time that amount. So that's going to go up. If it's negative, that's going down. So that's increasing. Okay. And then B, the y-intercept here, that's where you begin with. Okay. But keep in mind, this is in thousands. So 1.5 translates to 15,000. Okay. And 5.8 translates to 5,800. Did I say 15,000? I meant 1,500. 1,500. Okay, so remember that this is the beginning, this is the initial value, and this is how much is changing each year. All right, Sarah's bike buys a new bike. The total cost of the bike, including taxes, is $349. She pays $100 down and then agrees to pay the balance in 6 equal payments. Which of the following values is an appropriate representation of the amount of each of the 6 payments? Okay, so this is what you do. First, we're going to start where we begin with. Now, if I wanted to do y equals mx plus b, I could. It's the same thing. I just like to start off with what I begin with. I begin by paying $100 down, and then I'm going to make 6 payments. Okay, so 6 times the 1 payment, 2 payments, 3 payments, or whatever that price is I'm making for the payments times 6 is equal to 349. Okay, so each amount times 6. Okay, so now I'm just solve for x. Subtract 100 on both sides. You get 249. Divide by 6, and x is equal to 41.5. So that's the answer. All right, solve the equation below. All right, so first we're going to do is collect like terms. 3p and 2p is 5p. Bring down a 3, still equal to 13. Do the opposite. Subtract 3 on both sides. 13 minus 3 is 10. Bring down to 5p. Do the opposite of multiplication, division, divide by 5. 10 divided by 5 is 2. P is equal to 2. All right, solve for B in terms of A, C, and F. So what we want to do is isolate this B so that you have, instead of having A equal, you're going to have B equal everything else. So see if you can solve that. Okay, so this is how you solve it. So I'm trying to isolate B, and it's being added with C, but then divided by F. We're going to do the opposite in reverse here. So we're going to deal with this division by doing the opposite, multiplying by F. So F times A is going to be FA, and then I'm bringing down to B plus C. Now I got B plus C. I'm trying to find B, so I do the opposite of adding C and subtract C on both sides. So I got F times A, or FA, minus C. Bring down to B, and this is my answer. Okay, you could also have it in a different order. You could have A times F minus C, or negative C plus AF, and so on. Okay, solve the inequality below. Okay, so first thing we're going to do is distribute negative 2 times V and negative 2 times negative 10. We got negative 2V plus 20. Subtract 20 on both sides. Get negative 24. Bring down this negative 2V. Divide by negative 2. And don't forget, when you divide by negative, you have to swap the inequality sign. And we've got V is greater than 12. Okay, solve the equation below. Okay, so to solve this one, first we're going to distribute the negative 2. And we got negative 2x. Negative times a negative is a positive. 2 times 4 is 8. Bring down this positive 15. Collect like terms. Get 23 here. Haven't done anything on the left side here. Just brought it down. Now, I like to move the letters to the left, so I do the opposite. Add 2x on both sides. 4 plus 2 is 6x. Bring down to positive 1. Bring down to positive 23. Do the opposite of plus 1. Subtract 1 on both sides. 23 minus 1 is yeah, sorry about that. I had made a mistake. Now I have fixed it. I've got a minus here. So I wrote the problem down wrong. But now it is minus, like it is right here. And everything else is correct. So I'm going to do the opposite and add 1. 23 plus 1 is 24. Divide by 6, and x is equal to 4. All right. Okay, here we want to solve for the inequality below. Okay, so here we're going to distribute the 4. 4 times 7 is 28. Q. 4 times negative 11 is negative 44. Bring that down. Over here, I'm going to collect like terms. 20Q and 4Q is 24Q. Move the letters to the left. Subtract 24Q on both sides. 28 minus 24 is 4Q. bring down the negative 44, bring down the 12. Move the number to the right here, add 44 on both sides. 12 plus 44 is 56. Then bring down the 4q, divide by 4, and q is less than or equal to 14. Alright, Marlon bought a new car. Move this out the way. He was curious what the value of his car would be after a few years, so he came up with the following equation to represent the value of his car: Y in dollars, X years after the purchase. So we got 30,000 times 0.81 raised to the X. They want to know what's the percentage. At what percentage did the value of Marlon's car decrease by each year? Okay, it's 19%. 19%. So remember, in the growth formula, you're going to have a addition right here. But in the decay formula, when it goes down, you're going to have a minus. So let's say we wanted to find 19% or have a decay formula of it decreasing by 19%. Okay, we would take that 19%, change it to a decimal, and take 1 minus that. That would get us 0.81. So to find that, what you want to do is go in reverse and subtract 0.81 from 1, and you get 0.19, and just change it back to a percent, get 19%. All right. The store sells both ice cream cones and air conditioners. The store manager records the sales of these two items and creates a scatter plot shown below. There's a correlation between the two variables, but not a causation. There is both a correlation and a causation between the two variables. There is neither a correlation nor a causation between the two variables. There is no correlation between the two variables, but there is a causation. So let me explain what correlation and causation means. Correlation means that you have, in this case, two variables that's moving in the same direction. As one increases, the other increases, or they actually move similar, or we might have one increase and the other decrease. And so that means they correlate. But you have to interpret to see if it's a causation. Does one cause the other to happen? Right? So take a look at this and see if there's a correlation and a causation, or neither, or both. All right, the answer is A. Okay, there is a correlation. Okay, is the ice cream cones, the number of ice cream cones sell, air conditioners also sell, right? All right. Now, the ice cream selling doesn't make you buy more air conditioners, but the temperature getting hotter may cause both of those. So temperature rising might correlate with those, or be a causation for those as well. But here, ice cream, the number of ice cream cones selling doesn't cause people to buy more air conditioners. So it's no causation, but there is a correlation. Gary has a list of 25 chores to complete. She tracked her progress at the end of each day in the graph, then found a linear model to represent the data. What is the function that best represents this model? So here, they've got the graph, right? It's drawn a line of best fit here for these, showing these dots here. And you just got to write the initial value and the change. Okay, so the change is all the same thing as the slope. So to find this slope, I count it down 5 blocks here and count it over 2. So it's down 5, -5, and over 2. So the slope is -5 over 2. You type this in the calculator and you get -2 over 5. Okay. The initial spot is where you begin with the 25 chores. So we put 25 here. Oh, I want to show that too. 25, 25. All right. One more question. The graph below shows the number of days per month that the average daily temperature is above 65 degrees Fahrenheit, and the number of visitors in thousands to the Science Museum per month. Which statement below are true? All right, A and B, and there is a linear correlation between the two variables as data points fit closely along a line of best fit. See? All right, there is a positive correlation between the two variables because one variable increases and the other variable also increase. And that is the EOC Integrated Math 1 review. I want to thank you for checking out Mr. Ware's videos. This was a long one, but have a nice day and thank you.